impact testing machine. So this is used to test the impact strength of the specimens. So this equipment consists of a striker which has got a weight of around 21 kgs, and this striker lever has got a length of around 825 mm. And in the case of Izod, we'll be able to lift this to an angle of 85 degrees up to this point. So this is at an angle of 85 degrees from this point. Okay, so this is for Izod. And when we actually lift this to this side, so we approximately get around 0.78 meters of height attained. So 0.78 is the height. Mass is given, which is actually 21 kgs. Is it visible?
Yes, sir.
The mass is given as 21 kgs. 21 kgs mass, and the potential energy gained is mgh. Mass into acceleration due to gravity g multiplied by the height, which is around this, will give you the energy stored in this. The same energy will be absorbed if suppose the specimen is stopping this, which is not allowing it to move. So therefore, we almost get this maximum energy in this Izod to be around 164, because we know that this is in, so you can come here and show, these scales actually measure joules. So what you are getting here is 164 is actually joules. So what is joule? Joule is actually Newton meters. So 21 kg into 9.81 gives you around 205 or 210 newtons. 210 newtons into this height will give you approximately around 160 joules, 164 joules. And again, you can actually calculate the height of this from this point, and the height of this from this point is the radius of this swing arm. Now the radius of the swing arm plus this height. This height is actually a radius multiplied by sine 50 degree, because this angle here is mentioned as the angle here for the Charpy is actually mentioned as 140 degree. So therefore it is 0 to 90, 90 plus 50 it becomes 140. So therefore this is 90 plus 50 it becomes 140. So this is 50 degree. So if you want the vertical height, it is sine of this radius. So sine 50 degree into this radius plus this 0.825 meters will give you the total height gained from this to this. That is h. That h multiplied by mass into gravity will give you a value of joules, which is approximately, which is around 300 newtons. Now for us, when we calculated, it came to be around 299 or 298 something, but it comes to be around 300 joules. So this is actually Newton meter, so much of newtons, mg into h, so you get less Newton meters. So 1 Newton meter is 1 joule. In that way, we get this energy in terms of joules. So now, for the case of Izod, we keep this striker, the pendulum at this angle, and allow this to swing and actually break the specimen. Suppose if the specimen is not absorbing any energy, suppose if there is no specimen at all, then it will swing by the same height to the other side, it will show 0, which means that no energy is being absorbed. Suppose if this stops at this point, which means that all the energy, all this potential energy is absorbed by the specimen. So that potential energy is actually mass into G into H, which we calculated, which comes to be around 164 joules. In this way, so the potential energy stored is used to find out the impact energy. So here we have actually placed the specimen. So now the specimen is actually similar to this. Now the specimen is very similar to this. So where there is a notch, and now the area below this specimen is actually 8 mm. So 8 mm into 10 mm will give you 8 mm square below this notch. So 8 mm square of material is going to absorb the energy. So whatever the joules of energy that we get here, divided by that 8 mm square will give you the energy absorbed per mm square of material.